Welcome back to another edition of Pre-Calculus. This is Pauli division and factor theorem with Mr. Wharton. That's weird. I don't know. Sorry. I'll try not to do that again. All right, polynomial division and factor theorem. We're going to do a couple different divisions today. We got long division, we got synthetic division, we got synthetic substitute. We got a whole bunch of division. Yeah. Let's get it. So long division, we're going to start off with some long division problems first, just to kind of get you back in the swing of things so we can kind of go from there. But this is an Algebra 2 skill. We did this in Algebra 2, long division. Let's see what we got. Okay, here's the deal. What we do is whenever we're dividing, we take the division piece, we're going to write it over here. So x squared plus 2x plus 1. We are now going to divide like we did back in, I don't know, 5th grade when we talk about division of stuff. Now, if I look at long division, there's a 4 here, and this is really a 1. Okay, because I skipped terms, skipped degrees, like 3 and 2, I have to write those. So it's 0x to the 3 plus 0x squared plus 3x minus 1. Now, here's the deal. Here's what's going to happen. I'm going to divide. X squared times what is 2x to the 4? Well, 1 times 2, x squared times x squared. Okay? Now I'm going to distribute this with all of those. Okay? 2x to the 2 times x squared is 2x to the 4. 2x squared times 2x is x to the third, 4x to the third, right? So that's going to go underneath the 4x to the third, going to go underneath the x to the third column. 2x squared times 1 is 2x squared. Now those are all positive, right? These are all pluses. Here's what now happens. Now I'm going to subtract them. When I subtract, these pluses are going to change to a negative, or the negatives would change to a plus. You're going to flip the sign. So 2x to the 4 minus 2x to the 4 is gone. There's nothing there. 0 minus 4 is negative 4x to the 3. 0 minus 2 is negative 2x to the 3. And then these all drop down. Plus 3x minus 1. Now I start all over again. 1 times negative 4. X squared times x is going to give me that. So that gives me negative 4x to the 3. 4x times 2x is negative 8x squared. Okay, this is squared. Sorry, this is squared. Negative 4 times 1 is negative 4x. Again, I'm subtracting, so these are going to change to their opposite sign. So plus, plus, plus. These are going to cancel. Negative 2 plus 8 is 6x squared. 3 plus 4 is 7x minus 1. That just drops it like it's hot. Then I do it again. 1 times 6. X squared times nothing because x squared is already there. So then I distribute. 6 times that is 6x squared. 6 times that is 12x. And 6 times 1 is 6. Now I subtract, so I change the sign. So negative, negative, and then a negative. That goes away. 7 minus 12 is negative 5x. Negative 1 minus 6 is negative 7. This right here, I am done because this is a 1. The degree there is 1. That's a degree of 2. When the degree is less over here, we're done. This is what we call the remainder. Okay, this is the remainder. Here is how I write it. I take what's on top. Okay, take what's on top. 2x squared minus 4x plus 6. I take the remainder. Now, if the first piece is negative, okay, really what I'm doing is this. So let me back up a little bit. Really what I'm doing is I'm adding the remainder, negative 5x minus 7, over what I was dividing it by, x squared plus 2x plus 1. But because this term is negative, I'm actually going to take out the negative term. So it's going to be 2x squared minus 4x plus 6 minus my fraction of 5x plus 7. I took a minus out of both of them, right? So this becomes positive, that becomes positive, over x squared plus 2x plus 1. If, okay, if this right here was 5x minus 7 and not negative 5x minus 7, then it would stay as a plus right in here. Okay, we got to remember that. If the first term is negative, then I take out a negative out of everything. All right, there is your final answer. That is what it looks like. Go ahead and pause the video. Do number 2.
Hi, I'm Taylor Swift. I'm going to break up with another boyfriend and write a song about it. Pause the video.
Same process here. I take the 2x plus 7 and I put it on the outside. I have the 4x to the 3 plus 30x squared plus 74x plus 64. Now I divide. 2 goes into 4 twice. X goes, and I need an x squared. Okay, that is going to be 4x to the 3. Multiply there, that's 14x squared. Change the sign, minus, minus, cancel. This is 16x squared. Drop, drop. So that gives me plus 74x plus 64. 2 times 8, x, right? Then I get 16x squared. That's 56x. Then this is, I subtract, change the sign, subtract, cancel. This is 18x plus 64. Multiply by 9. So I get plus 9. That's 18x. 9 times that is 63. Fantastic. So I subtract, change the sign over here, cancel, I get 1. So 1 is my remainder. My answer, 2x squared plus 8x plus 9 plus 1 over 2x plus 7. That is your answer there. Hopefully that's enough practice for long division. We're going to now move on to something different. Okay, synthetic substitution / synthetic division. This is actually pretty cool. Synthetic substitution basically is we're taking the number. You can direct substitute. Remember we talked about direct substitution way back, I don't know, beginning of Algebra 2, is where I could take this number and plug it in, and then get a value, right? That's direct substitution. But I want to do synthetic substitution because that's going to help us with the rest of the section. So let's show you how that works. So what I do is I make this funny looking box, all right? Then on the outside, I take the number that I want to evaluate it at, which is 3. On the inside, I take the coefficients of my numbers, my terms. So 2, -5, 10. But if I look, there's 3, there's 2, there's no x to the 1, so that's a 0. I can't, remember, just like in long division, I can't forget that 0. Here's the rule. We drop the first one like it's hot. We multiply the number over here times the bottom number to get the next number. 3 times 2 is 6. We add 1. Multiply, add, multiply, add. So now, synthetic substitution, whatever the last number is what your answer is. So f of 3 equals 19. Okay, f of 3 equals 19. I want you guys to pause the video and do number 4.
I'm Slim Shady. Yes, I'm the real Shady. All you other Slim Shadys are just imitating. Pause the video.
Okay, so here's how I set it up. I got -5. I got a 1. There is no x squared term, so that's a 0. -3 is your x term, and there's no number over here, so that's a 0. I got to add those zeros in, otherwise it's going to be wrong. So I drop the first one down. I multiply, add, multiply, add, multiply, add, multiply, add. So -82, hopefully I did the math right, f of -2 equals -82. Let's see, 10, 11, -22, -22, it's 44, 41, -82. Okay, yeah, sounds good. So -82 is your answer. If I would have plugged this in to a calculator to all of my x's, then I would have gotten -82. I think that was quicker because it actually took me less time to do it that way than it did to plug all that in a calculator. Well, the question might be like, When can we use synthetic division? When they have a polynomial function, which is right here, polynomial, when you're dividing it by a linear term. Linear term. This is a linear because it's to the first power. If it was n squared or n to the third, I could not use it. So you would have to use long division in that case. Okay, but because this is linear, I can now use it. So I'm going to write my numbers like this, right? Coefficients 2, -10, 30. Oh, wait, no, that's wrong. What did I do? 2, -10, 0. Remember, there's x, this is n to the 2, is 0 of them. 30, then 28. Okay, 4, 3, 2, 1, 0, 4, 3, 2, 1, 0. Now, the number that's in here, this is n minus 3. That is not go over here. It's just a number. How do I figure out what that number is? I take the linear term, I equal 0, and I solve. N equals 3. So now this is going to be a 3. That's how I do it. So now I just do the same process. I'm going to drop it like it's hot, multiply 6, add -4, multiply -12, add -12, multiply -36, add -6, multiply -18, add +10. Here's what happens. Since this is my last term, this is my remainder. Just like in the previous examples, this is what the actual answer was. But now I'm actually dividing it, so I want to get the remainder. So here's what happens. I'm going to take the 2. I'm going to write the n. I'm going to drop this power -1. 4 minus 1 is 3. -4, n to the 2. Always now go down in order. 3, 2, 1, 0, remainder. -12n minus 6 plus 10 over n minus 3. Okay? That is how you write your division out. Much easier, much faster than long division. All right? Fantastic. Let's go to the next problem. Again, I want to take the 2x plus 3. This is linear, right? This is a 1. So I'm going to take the 2x plus 3 equals 0. And I get x is equal to -3/2. So that's my number on the outside. Numbers on the inside are 2, -5, and -12. Just because it's a fraction over here doesn't mean we can't do it. Drop the first one down. Let's multiply. If I multiply 2 by something over 2, that just goes away. So it's just -3. Let's add. I get -8. Let's multiply. -8 times 3/2. -8 divided by 2 is 4. 4 times 3 is 12. So this is now +12. I add, I get 0. Okay, so this right here is really 2x. Remember, I take this number, I minus 1, I get 2x minus 8. Here's the problem. Well, first off, this is a remainder, so it's 0. So that means we're good. There's no remainder because it goes in evenly, so there's good. Here's what happens with synthetic division. When you have a fraction for your outside number, at the end, you must divide by the denominator. I'm going to abbreviate denominator to denom. When you have a fraction for your outside number, which you do, you must divide by the denominator. So I have to take this and I have to divide it by 2 because that's what the rule is. That's a rule. Rule. We don't break rules. We follow them, or we try to anyway. So 2 divided by 2 is x. 8 divided by 2 is 4. So x minus 4 is my answer for this problem. That's a rule. You have to do that. That's the only thing about synthetic division that's weird. All right? That's the only thing you got really to remember. Okay, everything else is pretty self-explanatory, but that's it. Let's go on to the next one. All righty. Remainder theorem. Here's what it states. If a polynomial f of x is divided by x minus k, then the remainder r is equal to f of k. So this is really r equals f of k. What that means is this. If I said I'm dividing, this k is just a number. This is just some number, okay? So if I'm saying I'm dividing by x minus 2, that's a factor, okay? We're dividing by x minus 2. Then, remember, this is the 2 on the outside. I got to flip the sign. I have all my work, and I get all my numbers. And then over here, this is, say, a 5, okay? So 5. Then, this remainder theorem says that if I took f of 2 and plugged it into the equation, then I get 5, which is what we've been dealing with already, right? Direct substitution. If I plug in a number and the number at the end is my remainder, that's the same thing. If I plug this in, I get 5 out. That's exactly what we just did. Factor theorem. X minus k is a factor of the polynomial f of x if and only if f of x, I'm sorry, oops, that's bad, f of k equals 0. That means that if I took, so this will say x minus 3, I put the 3 outside the synthetic division, I got my numbers, and then over here is a 0, that's a 0, that means that it's a factor, it goes into it evenly, it goes into it nicely, okay, that would be x minus 3. So x minus 3 is a factor if that's a 0, okay? And again, x minus k, not necessarily x minus 3, but that's what happens there. Okay, this is where it's going to get a little tricky. We got to understand what this means. We're going to now literally throw everything together. Okay, we're going to throw it all together, and we're going to hopefully it sticks. It says, here's a polynomial function. I want to find the other zeros if it gives me one of them. All right, so since this is a 0, it already tells me it's a 0, so that number is going to go on the outside. If it said x minus 3 is a 0, then it would be still the 3 on the outside. Remember, we got to flip this one, but we don't flip this one. Okay, just remember that. I take the coefficients, boom, 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 2, negative 20, 66, negative 72, drop, multiply, add, multiply, 42, I believe that is. Add it up, 24. 24 times 3 is 72, so I get a 0. So it says it's a 0. That gives me a 0, so that means it's a check. That means I know it's a 0. We're good. Then I take the numbers on the bottom. Remember, I got a minus 1 from that, so it's x squared minus 14x plus 24 equals 0. Okay, I want to solve it. So I got to factor this out, so I'm going to take a 2 out. I get x squared minus 7x plus 12 equals 0. I'm going to factor this, right? So that's 12 and negative 7, negative 4, negative 3. So I'm going to skip some steps here, but you get the 2 from the beginning times x minus 4 from here times x minus 3 times this is also x minus 3 equals 0. So it says find the other zeros. So we already know this was a 0 of 3. Well, then I could use the same process here. Well, that's also a 3, and this is a 4. So my answers for this one are 4, 3, and that's it. I don't have to write 3 twice. There's 2 3s, but only write it once. So you have a 4, you have a 3, I'm done. That's all the other zeros. All right, number 8. It says 1/2 is a 0, so that means that 1/2 is going to go on the outside. 2, negative 17, 90, 41, negative. That means this number here should be a 0. Hopefully it is. Drop the 2 down, multiply, that's 1. This is negative 16. Divide by 2 is negative 8. Let's drop it down. That's positive 82. Divide by 2 is 41. That gives me 0, so that's good. Remember, it said if I have a fraction, I divide these by the denominator. So I really get 1x squared minus 8x plus 41 equals 0. Factor this out. 41 negative 8. Guess what? That doesn't work. Oh my gosh, what happened? What did we do in the last section when that didn't work? I'm still solving it. Remember, quadratic formula. Negative b plus or minus the square root b squared minus 4ac over 2a. So negative b is going to be 8 plus or minus the square root of 64 minus 4 times 1 times 41 over 2 times a, and 2 times a is 2, okay? So I get 8 plus or minus the square root of 64 minus 164 over 2, which is equal to 8 plus or minus the square root of 100 negative over 2 equals 8 plus or minus. Now, remember the negative on the inside is an I. It's the square root of 100 is 10. So it's 8 plus or minus 10i over 2. But that's equal, I can divide them all of them by 2 here. So it's 4 plus or minus 5i. Okay, so answers are 4 plus or minus 5i, comma, 1/2. And those are my answers for number 8. All right. Remember, just because it doesn't factor doesn't mean we can't solve it. You got to use the quadratic formula, the quadratic formula. All right, number 9. This last page here hopefully will be a little bit easier and faster on our notes here. The work was pretty much done on the first page, except for the next question, I guess. I don't know. I don't even know what I'm talking about. I don't even know what day it is. What day is it? Siri. Okay, Google. What day is it?
It is Saturday, the 13th of October, 2018.
Fantastic. That's my Google Home. And my Google phone and everything else Google. Google, Google. Maybe I'm going to throw that video of that old lady saying, Google, hey Google.
Google. What is raining today? Water.
Yeah.
Oh my God, it answered. It said yeah.
You say yeah.
Yeah, it's her.
Oh my God. It's a woman?
Yeah.
I'm glad to meet
What
you.
is this thing?
Hello, Google.
Hey or okay?
That's something from the
Google.
Alphabets.
You have to say hey Google or okay.
Hey, Google. Okay, Google.
What's the weather?
Yeah.
What's the weather? Ask.
What the weather? You want to know what is the weather?
Tomorrow.
Tomorrow.
In Flagler Beach tomorrow, there will be showers with a high of 65 and a low of 56.
With this. It's a mystery.
Watch it, man.
I'm scared. I'm scared. It's a mystery. Oh my gosh. No.
Ask Google to play an Italian song.
Cuckoo. Hi, Cuckoo.
You have to say hey or okay.
Hey, okay.
Google.
Tomorrow in London, it'll be sunny with a high of 41 and a low of 30.
I wanted it for a minute.
It's the temperature in London.
Mom, I asked her to play your favorite song.
Play your favorite song.
Cuckoo. Cuckoo.
Yeah, you're cuckoo, all right.
Cuckoo. Play a song for me. Piemontesina bella.
You have to say...
Addio dei giorni passati. Addio.
So, okay, you don't have to tap it first, but to wake it up, you have to either say, hey, Google, or okay.
Hey, Google. Okay, Google.
Play an Italian song.
And then it'll
Play
light,
an Italian song.
so it has to light up after you say that, otherwise it didn't hear you correctly.
Yes.
You know è un salame perché mia capisci cosa dice. I got it.
You're stupid because I can understand everything I'm saying to you.
Hello, Google.
Hey or okay?
Okay,
Google.
do it.
All right, if x equals 3 is a factor of f of x, what else can we conclude? So if x equals 3 is a 0 of f of x, what else can we say? We know then that...
I don't know how to help with that yet.
Oh, it's still on. Oh, sorry. Okay, Google, you can stop now. There's an 8-second delay on that thing. It keeps listening to you for 8 seconds. I don't really want that. I don't know. That's like the NSA just still listening to you like over the phone, you know, stuff like that. I don't want that to happen. Maybe we should turn that off. Okay, let's get back here. If x equals 3 is a 0 of f of x, what else can we conclude? That means that x minus 3 is a factor of f of x. Whatever f of x is, because it's a 0, that means it's a factor. What else do we know? We know that if x equals 3 is a 0, that means x equals 3 is a x-intercept. Is an x-intercept. Okay? What else do we know? That might be it. That could be it. I think that's okay for right now. X equals 3 is an x-intercept. All right? Fantastic. Well, I guess we do know one thing. We do know one more thing. That if I plugged 3 into the function, I would get 0. Because it's a 0, that would happen, right? So that's why those 3 are always going to work when x equals 3 is a 0. All right, number 10. Given the graph of this function over here, this is terrible, but it's over here, use your knowledge of the factor theorem to find the exact values of all the zeros of the function. List them from largest to smallest. If I look at the graph, remember a 0 is where it crosses the x-axis. So it crosses here, 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 and here. Well, this one is a decimal, that one's a decimal, that one's a decimal. We can't figure out what those values are. I can figure this one out because this one's not a decimal. This is 3. Okay, that's 3. So here's what's going to happen. Because that's a 3, we know that I can do synthetic division, and it'll come, this number here would come out 0. Okay, let's make sure, but it should. 3, negative 8, negative 12, 24, and 9. 3, I'm going to drop this down, so that's 3. So 3 times 3 is 9. Add it, 1. 3 times 1 is 3. Add it, negative 9. That's negative 27. That's negative 3. Negative 9 gives me 0. Fantastic. So I'm good. That's what I wanted. So now I got to minus the 1 from the power. So I get 3x to the third plus x to the 2 minus 9x minus 3 equals 0. Well, from the last section, I have 4 terms. So I can factor. Remember grouping. I can take an x squared out of the first 2 times 3x plus 1. Remember, if the third term is negative, I got to pull a negative out, pull a negative 3 out. So I get 3x plus 1 equals 0. So now I can factor those. It's x squared minus 3 times 3x plus 1 equals 0. I take each of these individually. This answer here is going to be negative 1/3, right? This one here is going to, this is going to be weird, but it's going to be x squared equals 3 because I add the 3 over. Then I square root it. And when I do that, I get x equals plus or minus the square root of 3. So negative 1/3 is an answer. Plus or minus the square root of 3 is an answer. And what's my other answer? Positive 3. Okay. And it says from smallest to largest. So if you want to go smallest to largest, it would actually be this. It would be negative root 3, comma, negative 1/3, comma, positive root 3, comma, positive 3. Okay, and that is your correct answer if it says smallest to largest. All right, that is how we do that. All right, you didn't really think that there was a fundamental theorem of algebra, but there is. And it's also surprising that we waited until your pre-calculus class to tell you what this was. Isn't that weird? Shouldn't we told you this in like 5th grade and be like, no, this doesn't make any sense. Like, this is too hard. So what this means is if f of x is a polynomial degree of n, so that means that For instance, say I have 4x to the 7th power minus 12x to the 2 plus 7. Say this is my polynomial function. Well, the degree is 7, so the degree is 7. Then f of x equals 0, meaning when I solve this out, it has exactly n solutions. So this problem is going to have 7 solutions. If I had x squared plus 2x plus 1, this is going to have 2 solutions because there's a 2, that's the biggest number. Okay? Now, they could both be real or imaginary. Imaginary would be your eyes, right? We had those already. So those all count, but it could be real or imaginary. One of those are all considered your answers. Imaginary zeros will come in what we call conjugate pairs. Conjugate pairs. In other words, each imaginary zero has a conjugate buddy. Buddy! So there won't ever be just one.
Are you watching the kids?
Oh, don't worry, I have them on the body system.
Body system?
Yeah, have a look. Buddy! Buddy! Buddy!
Here's what I mean by that. If 3 plus 2i is the zero of a function, name one other zero. What happens is I take the imaginary part. Take imaginary, imagine dragons, imaginary part, okay, and I flip the sign, flip it. Flip, I'll say the sign. And rewrite. Rewrite. So 3 plus 2i. So the imaginary part is positive 2i. So I'm going to flip it to its opposite sign. So now it's negative 2i. And rewrite, I'm going to rewrite everything there. So it's 3 plus 2i is the other zero. Okay? Take 2 seconds to pause it and try the next one. So if this is 7i minus 5, square root of 5, the imaginary part is the 7i. Some of you probably wrote it like 7i plus the square root of 5. Well, no, I got to take the imaginary part and flip the sign. So it's positive 7i here, so it should be negative 7i minus the square root of 5. The only thing that changes is the imaginary part. The real part, which is the square root of 5, doesn't change yet. Okay, so only the I imaginary stuff. All right. Fantastic. This video was a little longer, I know, and I'm very sorry, but it was a lot of good information. All right, have fun and deuces.